So here we are at Jerry's, beautiful grocery store. Great view, great elevators. We'll show you some of the basic laws of physics once we step into this beautiful machine. So some of our hypotheses for this experiment is that when we accelerate upwards, our weight is going to increase. And when we decelerate, when the elevator is slowing down, our weight is going to decrease. This is going to be a very fun project. I'm so glad that you're joining me with this. Well, hello again. As I step into the elevator, I have the same force normal as I did outside of the elevator. Now, when you see, we're about to accelerate upwards, and that's when I will feel more force on my legs because there's more force of gravity, because my force normal changes. Now that I hit a constant velocity, my force normal is the same as before I stepped into the elevator. Now we're decelerating, and as we decelerate, our force normal gets smaller because there's less force of gravity. So the first thing we have to do in finding our apparent weight is converting pounds into newtons, because I know that I am 210 pounds, and for every pound there's 4.44822 newtons. So my force of gravity is negative 934.1262 newtons. So now we can use this to find our mass. Force due to gravity equals mass times gravitational force, which equals, my mass is 95.319 kilograms. And we can figure out that our force natural equals 934.1262 because it's an equal opposite force with our force of gravity. So to find our acceleration, or to find our weight when the elevator is accelerating upwards, we have to find our net force first, which is mass times the acceleration of the elevator. So our net force equals 113.42961 newtons. So now to find the force natural, we have to get our original force natural on non-moving ground plus the net force when the elevator is accelerating upwards. So that force natural when the elevator is accelerating upwards is 1,067.5558 newtons. And then we have to divide by 4.44822 to get our pounds. And my pounds when the elevator is accelerating upwards is 238.1767. Now, when the elevator is decelerating, or it's coming to a stop, to figure out our force net, we do mass times its acceleration, which equals negative 53.37864 newtons. Now to find our force natural, we have to do the same thing as finding our acceleration upward. We take our weight in newtons on flat ground, and then you add that to your force net, which would be subtracting because the force net is a negative number. So our force natural when the elevator is decelerating is 880.74756 newtons. And you divide that again by the conversion to pounds, and that equals, in pounds, 196.4989 when the elevator is decelerating, coming to a stop.